Hey guys, BuildZoid here, and today we're going to be taking a look at the RX 6900 XT gaming PCB from MSI. And before we get into this, the PCB pictures are from Tech Power Up's review of the RX 6900 XT Gaming X. So I'll leave a link to their review down in the description. You should check it out if you want any information like thermals, power consumption, things that I'm not going to be covering in this video because we're only going to be looking at the PCB. And before we get, so thanks to Tech Power Up for the high-res PCB pictures and, allowing people to use them for stuff like this. Before we get into this, what you should be aware of is there's two versions of the gaming. There's a Gaming Z, and as far as I'm aware, they both use the exact same PCB, and there's a Gaming X. The Z has that's the 6900, what I call a 6900 XTK, because, why would you give different different names to products with different functionality? And then there's the Gaming X, which just uses the regular 6900 XT chip. The difference being that the XTK has a 4 GHz core clock limit and a 2600 and 24 MHz memory clock limit, whereas the regular 6900 XT has a 3 GHz core clock limit and a 2150 MHz memory clock limit. Now, if you're on air cooling, the XTK really doesn't give you much, if any, advantage. If you're doing more extreme overclocking, you really do want the 6900 XTK, because yeah, you're probably going to run out of the core clock frequency slider if you don't get the K version. So, yeah, and so you basically, the Gaming Z is the good one. Okay, the Gaming X is sort of like the old limited one. Anyway, with that out of the way, let's get into this PCB. And this PCB is probably the most custom 6900 XT there is, because MSI has just completely rearranged the VRM. So this over here is vCore. Then these three phases over here, and these are actually a real mystery to me as to what's going on with them. But I do know what they're powering. I'm just not sure which one's doing what. As far as I can tell, it's memory power, then you have VDDCI, and then you have more memory power under that, which is super strange. Why wouldn't you just put your two memory phases next to each other? Then you could have one piece of copper, connecting both phases together instead of doing this. And yeah, I'd love to know the answer to that. Maybe the power planes internally look like some kind of weird U-shape, which still is that probably isn't optimal. However, yeah, the thing is, I'm judging this off of the fact that if you look at the back of the card, it's there is a very clear split in the copper right here, which probably also goes under this silk screen over there. So you can see that, this is not one continuous piece over here, but the same is true also up here. So it's this is a different, power plane from the other two. It's not really much of a plane, but you get the idea. These are different, I'd assume they're different voltage planes, and so, and the thing is, there's not two separate memory rails, okay? There's one memory rail with two phases in it, so it's yeah, that right there is super weird. So that's super weird, but it ultimately, it's just kind of this is one of those uncertainties that I just have with, well, I don't have the card in hand, but it also isn't real, it's weird, but it doesn't inherently mean anything bad. It's just, yeah, that's weird. Normally you see phases put together because, for convenience, but yeah, I'd love to know what the reason for doing this is. Anyway, the other super strange thing is just the vCore VRM itself and also the SoC VRM. So, the SoC VRM is here. And that's two phases. So the wacky thing is that the SoC VRM, normally, unlike any other 6900 XT, would be there. But MSI decided to put it over here. Which might, the problem I have with this, and completely reshuffling all of the phases like MSI has done on this card here, is that depending on how the BGA is configured, this could actually significantly increase how much power you're losing in the power plane. just because now the power from the SoC rail has to travel that much more distance in order to get to the core. And, you know, the thing is, the core orientation hasn't changed. This is the same orientation you would see on any other 6900 XT. And the reference design has the SoC VRM over here. In fact, the vast majority of 6900 XTs have the SoC over here. So, like, I would assume that the BGA probably has, like, SoC coming in somewhere through this area. It could also be coming entirely through the center of the BGA, in which case it really doesn't matter where you put it relative to the core because, yeah. And also, it's not that much of a difference in distance, but yeah, this is a very weird design decision where it's like you don't normally see manufacturers just completely rearrange their power planes like this from the reference design, because generally the BGA is going to reflect the which solder balls are being used for power. Is going to reflect the reference PCB's VRM design quite significantly, especially on NVIDIA GPUs. And I'm not sure if this is true of the the newer ones, but on older NVIDIA GPUs, if you look at those PCBs, there's always a vCore power plane that comes in from here, and you basically have vCore sort of like this coming into the chip. So you have a bit coming in through this corner, and then most of the connection is actually made directly under the die. But yeah, so I would assume that with a card like this, you know, there would probably be some amount of vCore connect. Like, if I had to guess, then the BGA for this looks something like that when it comes to vCore. And, you know, VDDCI, like, your memory power sort of goes all around, so that just never changes. Like, your memory VRM can be basically anywhere. The VDDCI would normally be located up in this area of the PCB, so I would assume that it sort of comes in through this side of the chip, and maybe sort of like that, something. Then again, also VDDCI is for the memory controller, so you'd probably have a bit of a ring of VDDCI around the whole chip. Because normally there's I've not checked this for Navi cards, but on older AMD GPUs, you'd have 4 VDDCI capacitors going around the whole core, even though the VDDCI rail comes in from one area, because the memory controller wraps around the whole chip. So, you know, you're gonna your memory controller power sort of has to go in the same areas. Yeah, and then the SoC rail, I would assume that normally comes in through this area, because that's where it would normally live. So it's very interesting that MSI has just completely reshuffled the power planes. You know, theoretically, this could lead to slightly more power loss in the power planes, and that's sort of the worst case scenario for this. It shouldn't really, assuming that the card is still designed well, it's it shouldn't really cause any other issues than that, potentially. So yeah, but it's very interesting that they've rearranged it like this, because yeah, I've not seen any other manufacturer do that with a 6900 XT, and it's one of those things that, this is sort of the only thing that concerns me with this card. Is just this doesn't use the standard layout, and that's kind of might be suboptimal. Anyway, down here we have, of course, more vCore, and then above we have yet more vCore. And also you can see sort of MSI's wrapping the vCore power, you can see here, they're pulling the vCore power plane up and around like this. So I'm assuming eventually it ends up you probably have some current doing that, which is just yeah, I don't know, guys, that really doesn't seem like a good idea, but the thing is, it's also not really fair to judge how the power delivery is done from looking at the top layer of the PCB, because GPUs will generally have lots of PCB layers. I don't know how many PCB layers this has. There's no layer count indicator anywhere that I've been able to spot. But yeah, potentially internally, there's just a vCore power plane that just goes something you could have a vCore that just looks like that. And it's just sort of everywhere, which would be, you know, very, very reasonable. But yeah, from the top layer, this looks just super strange. So, and potentially suboptimal, because this, you don't actually want current doing that. There's a decent chance that, there's also a chance that the current can just sort of go like that, but we can't see under the memory chips. So I don't know if there's a vCore connection going on down there. There could be. It's just yeah, not visible. Now, so, strange VRM layout aside, I really, really like what MSI has done here with this card, even though I've just been sort of complaining about, this doesn't look optimal. the thing is so it's not the most powerful VRM on a 6900 XT, but it's more than powerful enough. Actually, wait, how do I? It's been a long time since I've last done a PCB breakdown. I've sort of forgotten the order in which we do things. So we're gonna go back to the front. I'm not reshooting this video. There's been multiple failed takes at this point. Mostly because I was experimenting with integrating some stuff into the video, and then I decided, this doesn't work. So, anyway, so we've got, wait, did I delete? Okay. You've got VCore, which is 12 phases. Then you've got SOC, which is still 2 phases, which is normal. Then you've got your memory power, which is a 2-phase, and you've got VDDCI, which is a single phase. So this is not the highest phase count you can get for VCore. The highest phase count you can get for VCore on a 6900 XT is 14 phases. But the thing is, the difference between a 14-phase and a 12-phase is not that big. And like, it really isn't that big. That's, that's like, yeah, it's well, like, I even have the efficiency for like a 14-phase version using the same power stages, so we'll get into that. So 12-phase VCore using the TDA21472 70 amp smart power stages from Infineon. And yeah, should I explain what smart power stages are in every video, or can I just sort of assume that at this point people know that what they are? I'm gonna go with, screw it. I'm gonna just go with people know what smart power stages are. So yeah, 70 amp smart power stages from Infineon, which is sort of the same power stages that you'd see on most 6900 XTs, that at least from what I've seen so far. And the result of having 12 phases of those is that this VRM is capable of pushing 1.2 volts at a switching frequency of 400 kilohertz. This is just what the datasheet is spec'd at, though it's worth noting that if you actually have a 6900 XTK, the voltage slider in the AMD driver goes up to 1.2 volts. So, yeah, this is actually a very reasonable voltage to like, discuss the efficiency of the VRM at, because that's a voltage you would totally use. Like, I would totally use that. There's no reason to run less than that unless you're having cooling issues. So anyway, 1.2 volts, 400 kilohertz switching frequency, 300 amps output, and you might be like, wait, why are you starting at 300 amps? Well, after my experiences with the Red Devil Ultimate, these cards pull a hell of a lot of VCore current, like so much current. So anyway, at 300 amps, this VRM should produce about 24 watts of heat. At 400 amps, it should produce about 36 watts of heat. And then at 500 amps, it should produce about 51 watts of heat. And 600 amps, it should produce about 72 watts of heat. So basically everything past that 400 amp mark. And so like MSI sort of gets like the whole putting the SoC VRM in the middle of the VCore is actually sort of beneficial for VCore VRM thermals, because you essentially, like, the SoC VRM has very little work to do. Like, every single rail on the 6900 XT except VCore basically doesn't have to do much of anything, and VCore is just supplying stupid amounts of current once you disable the power limits. So the thing is, like, having the SoC VRM in the middle of the VCore VRM means that you've effectively lowered the heat density of the VCore VRM, because you don't have all of the power stages right next to each other heating each other up. The SoC VRM basically can act as a kind of miserable heat sink for the rest of the VCore VRM by being in the middle of it. Then also by having 2 phases over here, you further reduce the thermal density. So yeah, there's some like the thing is like, this is a lot of heat that is also a hell of a lot of current, and just in general a ton of power. But yeah, MSI's layout here actually sort of spreads that heat out more around the board than some of the other layouts that you would see on 6900 XTs. Also, if we did have, say, a 14-phase 69, like if we had a 14-phase version of this VRM instead of the 12-phase version, the efficiency difference is like the 14-phase would be about 35 watts of heat, and at 500 amps, it would be about 47 watts of heat. So not really much of a difference. Now, you might be asking yourself, why aren't you talking about what it would be at 600 amps? See, before I got my hands on a Red Devil Ultimate, I had no idea it was possible to push that much current through a 6900 XT. So I didn't really, like, I don't have calculations for 600 amps for the Red Devil Ultimate PCB, because I did that before I actually had a card to play with. So, yeah. And ultimately, like, so at 600 amps, the difference would again be more significant than it is at 500 amps. You already saw that, like, at 36 watts, at 400 amps, the difference was a watt. At 500 amps, it was like 4 watts. At 600 amps, it would probably be like 10 or something. Yeah, probably be like 10 or something. So, it would be kind of a significant difference, but also at this point, you're well into LN2 overclocking territory. And at that point, you don't actually need the VRM to sustain the output current for longer than the duration of the benchmark. So you don't have to worry about that as far as I'm concerned. On with LN2 overclocking, you can get away with some really, like, pretty horrible amount, like, really, really high current outputs, mostly because the benchmarks are so short. If there was like a 20-minute 3D benchmark, then this might actually be a problem. But there isn't a 20-minute 3D benchmark, so that's not an issue. We don't have to worry about that. And also you could always just run the card without like VRM heatsinks and put a fan on them, and then that would still be like this would still be manageable if you wanted to manage it. Though it is a hell of a lot of heat. So anyway, so in terms of VRM efficiency, like, yes, this is weaker than a 14 phase. It's just not by a significant amount. The SoC VRM uses 2 more of the same TDA21472 power stages, and the memory VDDCI and VMEM uses some alpha and omega semiconductor DR MOS components that I can't get a datasheet for because I can't look them up. I have no idea what the actual part number is, or if the part number that's actually on them is correct, then it doesn't show up on Alpha and Omega's website, because these are labeled 54700E, and well, if you search for that, you don't get anything. So I have no idea what those actually are. But they are they're not smart power stages, even though they do look a hell of a lot like smart power stages. And we know they're not smart power stages because this right here is DCR current sensing. So this capacitor and resistor are basically used to measure the current flowing through the inductor by the voltage controller, which is this chip right over here. And so because of that, these aren't smart power stages, because if those were smart power stages, you wouldn't be doing this. This is one of the big benefits of smart power stages, is you don't need that, right? Like, if you look at the VCore VRM, there's no capacitors and resistors being like next to the inductors, or on some cards you'll see them like behind the inductors, but again, like, same thing. You don't have anything directly behind the inductors because you don't need to do that, because the smart power stages do that for you. They're all, like, see, they're smart. They do your current measurements. So anyway, that's sort of what's going on with the power stage configuration of this card. The thing is, like, the SoC VRM doesn't really need to push any amount of current, and then memory and VDDCI need to push even less. Like, there's very little power going through the memory sys. Like, there's very little current coming out of the memory VRM. Like, on my card, when I was pushing it, it would sit around sort of like 15 amps at 1.35 volts. So yeah, you don't really, 15 to 20 amps at 1.35 volts, which puts us into the like 27 watts max memory power draw. So yeah, really not much power, not much power at all, because like memory doesn't pull a lot of power. That doesn't mean it can't get really hot. It just, like, it doesn't pull a lot of power. It's not something you need to like worry about a ton in terms of power delivery. It does still need cooling though, right? Like, that's why we have thermal pads on memory chips, at least on modern GPUs. In the past, on GDDR5 cards, which actually pull, like, you have cards with GDDR5 that actually gets really power hungry. No cooling on a lot of those. But anyway, so let's go to the back. So that's what's going on with the power stages. In terms of the controllers, for VCore and SoC, we have the XDPE132G5 from Infineon. 132G5, and this is a 16-phase controller, and as I already mentioned, it's running in 12 plus 2-phase mode for the VCore and SoC. And MSI is kind enough to give us the I2C header right there, so you don't have to go searching for it on the rest of the PCB. So this is very cool. If you want to hook up an Elmore EVC to this card to get proper voltage control, you do that right here. Now, what's not so cool is the voltage controller used for the memory and VDDCI rail, because this is an NCP 81022. And I am not entirely certain that this thing has EVC support yet. It should be able to have it, because it's not fully, it's not 100% digital off the top of my head. This is a controller commonly used on like R7 260Xs for VCore, so this is like most other 6900 XTs would use an IR35217, which is a much higher end voltage controller. However, it's also just doesn't matter. Like, just straight up, it does not matter what controller. Like, you like, I'm really surprised that most cards use a 35217. Like, that to me seems like a really excessive, like, that's an 8-phase controller. Why are you using it for a 2+1 phase memory rail? So this is a much more appropriate controller as far as I'm concerned, but I don't believe it currently is. I can't, off the top of my head, I don't know if it's supported by the Elmore EVC. So if you wanted to tweak the memory voltage or the VDDCI voltage, well, that might not work through the EVC. However, there is a public data sheet for this chip. You can get it off of like DigiKey, not from onsemi's website though, which is annoying. But yeah, there's a public data sheet, and it just has feedback pins, and there's like this thing's super easy to volt mod. This is in fact the very first voltage controller that I've ever volt modded. Yeah. So this thing, like, if like Buildzoid from high school could volt mod his GPU, then with one of these, then like no excuses as far as I'm concerned. It's like, well, actually, this is significantly more difficult than hooking up an EVC, but still, it's like, come on. Not that hard to do. Really not that hard to do. And also, probably unnecessary. Like, in my experience, you can gain some bit of stability by messing around with these two. Maybe it's not really, but not much. So... yeah, I'm not like this technically is a downgrade. I think it's also a much more appropriate part to use for what it's actually doing. Yeah, so this thing is sort of like, like, it's not an upgrade, that's for sure. So that's one of the things that this card does worse. But let's finally get to the thing that I like so much about this card, and that is that MSI, unlike everybody else making 6900 XTs, has proper filtering for everything. Like, the amount of capacitors that MSI has gone with is like, yes. This is where, like, basically when I was messing with my Red Devil Ultimate, this is the card that I sort of ended up going to, and I was like, oh, this is kind of what I want to end up with when I'm finished modifying my Red Devil Ultimate. Because MSI's input filter right here is all of these 270 microfarad through-hole polymers. For comparison, on your typical 6900 XT, you would have 6 of these on the entire card. Okay? Like, yeah. So this is obviously much better because MSI has 6 of them. Well, basically MSI has 1 of them per phase, which is probably, that's probably pretty excessive, but, I mean, there's no harm in having more capacitors, as far as I'm concerned. There's never any harm in having more capacitors. You can never have too many of them. So, yeah, MSI, so this is one of my favorite things about the card, is just, like, this actually has a proper input filter compared to all of the other 6900 XT. Like, well, no, like, this is the best input filter. There are some that technically are upgraded compared to the reference cards, but none of them go this far. Also, if you're wondering about where all of the multi-layer ceramics went, well, technically, normally on a 6900 XT, you would have one of these larger multi-layer ceramics on the front of the card for input filtering. Well, MSI just moved all of them to the back, which, yeah, I don't see any reason for that to be an issue. Like, it's actually pretty normal to have all of your input filtering behind, like, directly behind the power stage. So this right here seems perfectly like this is perfectly normal as far as I'm concerned. So yeah, MSI has basically taken the input filtering that you would find on a regular 6900 XT, and for this side of the VRM, they've like more than doubled the capacitance. I'm not gonna try to figure out how much more it actually is, but it's more than twice what you would normally get on a 6900 XT. Because not only is there more capacitors, they're also 270 microfarads each, whereas normally there's like 180 microfarad caps. So yeah, I'm a big fan of this. Then on the other side of the board, where there's just not enough space due to the heatsink that MSI is using on this card, they're using tantalum polymers for input filtering, which are extremely expensive. So I'm actually really surprised that they didn't decide to just like somehow squeeze in through-hole capacitors here. Because yeah, these things are just crazy expensive for how much capacitance they have. And again, we have basically 200 microfarads per phase, right? Because you have, these are 100 microfarads each on the back of the board. And then when we flip the board over, you've got, you know, another whole set of them. Oh, actually, it looks like the memory rail is missing one. Like it only has 5 instead of 6, but you know, close enough as far as I'm concerned. So yeah, like compared to all the other 6900 XTs, like MSI just has a vastly higher capacitance input filter, which in my opinion is just better. This should just be better. There's really no other way around it as far as I'm concerned. Like this is better. Other than that, for the output filter, we're looking at a similar situation where, as far as I can tell, like I didn't bother to count the multi-layer ceramics this time. Okay, like I'm not counting these. This is super annoying. But we have, you know, a nice mix of multi-layer ceramics. Then we've also got the through-hole polymers. These are 820 microfarads each, so these are big ones. 2.5 volts rated, which you don't need a high voltage rating for a V-core because this is like a 1.2 volt rail. And then we've got tantalums, which I'm personally not actually a huge fan of for like output filtering. For input filtering, they make sense because like aluminum polymers for like SMD aluminum polymers don't come in like higher capacitances than like 56 microfarads, which is like not enough. Right? Based on the fact that MSI has like 200 microfarads per phase. It's like you'd need twice as many capacitors on the board in order to achieve the same capacitance that MSI is shipping here. And it's just like, that is not really an option. But for output filtering, generally aluminum polymers can get you slightly lower ESRs than your tantalum polymers. So it's like, I think like they're better. But like compared to through-hole capacitors, it's just like the differences between SMD tantalum polymers and SMD aluminum polymers are very, very minor compared to the differences between like through-hole polymers and like any SMD capacitor whatsoever. So yeah, and on when it comes to the actual SMD tantalums, MSI is using way more of those than the reference card. So on the back of the card, so on the front for V-core we have 8 of them, and then on the back for V-core we have another 8 of them. Which puts the total of like SMD polymers for the V-core VRM on this card up to 16, whereas the reference card has 8. Literally half as many. And that's ignoring the fact that the reference card doesn't have any through-hole capacitors whatsoever for the output filter, which I don't actually think is, like, I don't think the through-hole caps are actually doing much of anything. I really think they're more like, I think these are more visually impressive than they probably are in terms of what they achieve electrically. Because in my I don't think these are necessary. I'm not entirely sure that these are achieving much of anything, but they certainly don't hurt by existing, right? As I've mentioned before, you can't have too many capacitors, like especially if it's actually designed from the factory to have this many capacitors. Like, yeah, you're not going to have too many. But yeah, like these are probably not I don't think these are actually functionally doing much of anything. I think most of the most of this VRM's voltage regulation performance will come from the multi-layer ceramics and the tantalums, but the through-hole polymers don't hurt anything by being there. So yeah, I'm not going to complain about them, right? Like this is just extra manufacture. Well, to be fair, this is one of the most expensive air-cooled 6900 XTs there is, but at least it saves me the effort of soldering a bunch of capacitors. Right? Like that's the way I look at it. And then of course you have more multi-layer ceramics up here. Though these ones I just find it like super questionable because it's like how are these connected to the core, right? Because ultimately all of the capacitors here are to basically deal with the well, you don't need this many capacitors to deal with the switching noise from the VRM. Okay, when you have 12 phases running at like 500 kilohertz, there's not much ripple getting through. The VRM isn't going to be producing a whole lot of ripple. The core, on the other hand, that is a major problem, right? Because the core can very rapidly go from pulling 100 amps to pulling 300 amps. And this, like the massive capacitor array that you have on a card like this is basically there to deal with that sudden jump in current demand. And so, you know, these are kind of questionable in like, well, does like when the core suddenly pulls a bunch of current, like how do these connect to that, right? Like that's the part that I'm confused about with these. But I'm really guessing there must be like just an internal vCore that just goes under the memory chips, because otherwise I have no idea why these would be where they are. So yeah, like MSI basically, like the main reason this is my favorite 6900 XT PCB, at least on paper, is because we've got much better input filtering than any other 6900 XT I've seen. Output filter looks also just better than any other 6900 XT I've seen. I'd love to try this. Like, I'd love to take an oscilloscope measurement of this card. It would be, yeah, like this would be a really cool card to check out under an oscilloscope and then compare, especially against like a reference card. Like, I think that would be, because the Red Devil Ultimate was kind of noisy, but it already has significantly more capacitance than the reference card. This, however, takes that to a whole nother level. Right, like there's twice as many large SMD capacitors. Then you also have, I think, the same number of multi-layer ceramics, or a similar number of multi-layer ceramics. And then you also have the 820 microfarad through-hole polymers, and it's just like, yeah, I don't think, like this is approaching kind of what like Galax does for their Hall of Fame cards. And I consider those the golden standard for VR, like GPU output filters for vCore. Like, it doesn't get better than what Galax does for the Hall of Fame cards. And this is really getting, like, yeah, and this is approaching that. So I really like what MSI has done here. And then in terms of the vCore VRM, like, yeah, this isn't the most powerful vCore VRM in terms of current handling capacity, but 12 phase versus 14 phase, in my opinion, isn't enough. Like, it's not a big enough difference to actually matter compared to the potential benefits of just having way more filtering than any other 6900 XT that I've seen. So yeah, that's why I'm a like a really big fan of what MSI has done with this card. The power plane situation I find very questionable, but like without actually having you know, schematics for every single layer, it's like I don't actually know where the vCore power, like I don't know what the vCore power plane looks like, right? The top layer doesn't show you anything. Like if you were judging what's going on with vCore by the top layer, you would say there's no way for the power to get to the core, because like this is where the vCore power plane ends. It never actually makes it. Like, actually, this is ground right here. So your vCore looks like this, right, on the top layer. So if you were judging the vCore power plane by looking at the top layer, it's like, how does the core even turn on? So that's obviously not a good way of doing things. But yeah, this thing right here is just like, that is super weird. But I'm really assuming there's just an internal vCore layer that just, like, there on one of the internal layers, there's just a massive vCore power plane that just sort of goes everywhere. Actually, it might even end up going something like this, because there's a bunch of there's a bunch of vias here. It's like probably connecting this part of the vCore, like the top layer of vCore, to one of the lower ones. So yeah, you know, not the most powerful, but certainly probably the best filtered 6900 XT there is, and definitely a card like I'd love to see this on an oscilloscope. And in terms of practical impact, I think this card would probably, like, on average clock maybe 30 megahertz higher, and honestly I think that's really pushing it. Like, you'd need to test a lot of cards to find a difference like that, and the thing is, the difference will get exaggerated the more power you push into the card. But yeah, the thing is, like, my 6900 XT definitely picked up with some of the, like, especially the input filtering capacitor mods I did. Like, those suddenly gave me like 20, 30 megahertz more. And it's just like MSI has basically done that from the factory. And then more than that, like this output filter is ridiculous. So yeah, this thing just looks like, yeah, like, well, if I had my way, there wouldn't be any empty space. It would be just capacitors. But this is close enough as far as I'm concerned. Other than that, MSI's done other neat things, like they've added input protection fuses. Also, which the funny thing is, I think PowerColor is the only manufacturer that does this. But when PowerColor adds an extra power connector to one of their GPUs, what they do is they don't add extra power filtering for that extra connector. They just run that connector through the input filtering of a different connector. So on the Red Devil Ultimate, these two, like this 8-pin and this 8-pin, would basically do that in terms of how they get their filtering. Whereas MSI has done sort of the correct thing where it's like, no, this 8-pin has its own input filtering inductor, this 8-pin has its own input filtering inductor, and this 8-pin also has its own input filtering inductor. Which I don't know what that means for coil whine, because these are also different inductors from what you'd see on the Red Devil Ultimate. They are higher inductance, so theoretically this should put less strain on the power supply. Also, the fact that you just have way more capacitance hanging out right in front of the VR, like right in before the VRM, means just, yeah, this really shouldn't be sending that much, like the transients from the GPU shouldn't be as big once they go through these inductors. Because that's what those inductors are for, is they're basically to force the VRM to pull as much current as possible from the capacitors on the actual card and not from the power supply. So yeah, anyway, now obviously eventually the current has to, like the output current of the power supply, like the current coming in through the 8-pin is going to have to catch up to the current going through the VRM, but the initial load transition is like going to be slowed down by the inductor, and the higher the inductance of these, the more so it'll be slowed down, which I guess might explain why MSI has so much more input capacitance. Is also, I think they're using higher inductance inductors than everybody else. But yeah, in terms of like when it comes to coil whine, I have no idea. That like just because one card has less coil whine after adding more input filtering doesn't, like, this is on different inductors, different capacitors, everything's different. So yeah, also like you could just have inductors that are inherently less likely to coil whine to begin with. So, you know, yeah, I'm not gonna mention that, but anyway, like interesting, like it's very interesting that MSI has, like what MSI has done here. Like this is definitely the most like custom 6900 XT I've seen. Other than that, you also have input protection fuses. So if for any reason something goes wrong with the card, these will minimize the amount of damage that occurs. Not prevent it, just minimize it. Because what tends to, like, what sometimes happens when you, well, okay, like if you have a card where you don't have input protection fuses like this, well, it's not really input protection. It's more like damage mitigation fuses, like this, is what can potentially happen is you can, on a GPU, let's say a power stage fails, which is not, that's probably one of the more common ways a GPU ends up dying, is you have a power stage die. So a power stage dies, and when a power stage dies, they very frequently fail short circuit. Now, depending on how fast your power supply is and how bad the short circuit is, you know, you may or may not end up in a situation where that shorted power stage pulls in so much current that it burns a hole through several layers of the PCB. Now, the idea behind having these fuses is that that fuse will hopefully blow before the power stage, like, completely destroys everything around it. And under it. The stuff that's under it is actually more concerning, because like if shorted power stages can potentially like weld themselves to the power planes that they're attached to. So these fuses are there to like minimize the probability of that happening. Not completely preventive, but it's far less likely, like the fuse will hopefully blow before it gets that bad. Whereas without the fuses, if you had a power supply that has a very high overcurrent protection or just very slow overcurrent protection, the thing is the overcurrent protection of your power supply could be faster than the fuses. But anyway, like these don't hurt anything by existing. So these are a good thing. They're not something like, they won't really make it if you know how to repair GPUs, these make your life easier. Other than that, they're not really that useful. So, and MSI has those on all of the 12 volt inputs. Actually, this, no, that just looks like a bridge. Or actually, I don't know what that is. Yeah, I have no idea what that is. It looks kind of like a bridge. Though, the thing is, MSI has these bridge resistors over here, so, Anyway, so we also have input fuses. So, yeah, I'm a big fan of what MSI has done with this card. Like, it honestly, like, this is as close, I think, an MSI card has gotten to being a old MSI Lightning card. Like, back when MSI Lightning cards were good, instead of just overpriced, this reminds me of those cards a lot. You know, I think like the biggest difference if this was an actual Lightning card would be that there wouldn't be any through-hole output filtering capacitors. It would just be a completely excessive number of SMD polymers. But I think it's for the best that MSI didn't do that because this thing's already expensive. Like this is where yeah, this is one of the most expensive 6900 XTs you can get. Especially like with air cooling. If you look at some of the water cooled ones or the one that comes with a like there are more expensive models, but this one's definitely not a cheap. This is not one of the cheaper cards. And yeah, if they switch the output filter from through-hole capacitors to polymers entirely and they still had roughly the same amount of total capacitance, this thing would be a lot more expensive, probably, because the through-hole capacitors are like a tenth of the cost of the SMD polymers, tantalum or otherwise. Like SMD capacitors are just ridiculously like large capacitance SMD capacitors are just very, very expensive. So yeah, but like like the thing is like yeah, if the I just love this card. This is what a 6900 XT in my opinion should look like instead of what most of them look like, which is just like stretch reference cards with a questionable amount of input filtering, especially for GPUs. Like if you lift the power limit on one of these things, they will quite happily pull in excess of 400 watts. And the more concerning part of that is that they'll also quite happily pull like way less than that. And they will, jump between those two levels of power draw very, very rapidly. So, yeah, I'm a really big fan of what well, actually, how long is this video? Oh, we can go on. It's less than an hour. I don't feel bad for wasting your time. So other things that I like, because yeah, it goes on. MSI has also cleared out the area around the GPU core of like tall components. So if you're into LN2 overclocking, that's really cool. Because on most 6900 XTs, these two voltage rate, so one of these is 0.75 volts, the other one is 1.8 volts. I'm going to assume this is 1.8 volts because it has this thing in front of it. Actually, this might be a switch now that I think about it. That might not be an LDO. That might be a switch. Yeah. I've not been sure about that. Unfortunately, I can't look up the part number for that stupid thing. But anyway, this regulator would normally hang out right here. And this inductor is a potential LN2 pot clearance hazard because it's right next to the GPU core. But yeah, MSI has kindly moved this inductor out of the way of the way of LN2 pots. So that's another cool thing. It's just like, yeah, like this is really giving me massive lightning vibes. Like I'm like if MSI, because I got really annoyed when MSI did the 2080 Ti Lightning, I think it was. Like that was not a lightning card. That was by no means a lightning card. This, on the other hand, if they put the lightning brand on this, I'd have no problem with it because like they've moved these. Like this is one of those things that, yeah, for LN2 overclockers, this is so helpful because you don't have to worry about like having an inductor right next to the core that's too tall so your LN2 pot doesn't fit. So yeah, and this like it's a minor thing, but it is a thing that actually is super annoying to deal with, especially with SMD inductors like this where you like need to put them on an extension cables or something in order to get them out of the way, or you need to get like a lower profile inductor of the same current rating, which potentially is not going to be that easy to do. So yeah, I'm a huge fan of the fact that like they moved these out of the way. Now, unfortunately, they also put these two Rgb headers, I'm guessing. Those don't look like fan connectors. I'm going to assume they're Rgb headers up over here, which that sucks. Like it was almost perfect. We were so close, right? Like you move the tall voltage regulators, then these two showed up. However, these I don't think are like these aren't really components particularly important to the functionality of the card. So this is the kind of thing that you can just desolder it and not worry about it, right? Whereas like this inductor is potentially a major issue depending on where it's located and how tall it is. So yeah, like this honestly is like, if they called this a lightning, I have no issue with it whatsoever, because this really is like MSI Lightning vibes. Not like the thing, again, past Lightnings, I don't think, like I tried to look this up because I wasn't sure about it, but yeah, like old Lightnings really didn't use through-hole capacitors for output filtering. So that's kind of like, But the thing is, I don't feel like that's a downgrade because you do also have the SMD polymers there. So it's just like, they're just kind of like extra. Like, if anything, this is like pushing this towards also like Hall of Fame, Galax Hall of Fame territory in terms of just the output filter design. So yeah, I really, really like what MSI has done here. I mean, we could also have 2 more phases, but I don't think that would have been that, like, would make that much of a difference. So yeah, that's the 6900 XT gaming PCB from MSI. Now, their 6800 XT card from MSI uses a 11-phase version of the V-Core, and then everything else is still the same. Well, I don't know why you'd get a 6800 XT for extreme overclocking, because it's locked, and there isn't an unlocked SKU, because, you know, welcome to the new world that we live in where AMD sells K and non-K GPUs. So, yeah, if you buy a 6800 XT, based on this PCB, you're not going to be allowed to go over 2.85 gigahertz core clock, which you can do on air cooling. You can do that on air cooling. You just need to shove a lot of voltage into the core, and then you can do that on air cooling. So, yeah. 6900 XT Gaming Z. Probably, like, if I was choosing a card to go, if I had an unlimited budget, and I was choosing a 6900 XT to take on LN2 with the minimum amount of modifications, it would be this one. Because this looks like it's the best one. So, yeah, anyway, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. And what else is there? Right. Also, one last thank you to Tech Power Up for the PCB pictures. And yeah, that's it for the video. Thanks for watching, and goodbye.